I guess I'm gonna kick this off.
Yeah.
So, so welcome everyone to the December 14th edition of the Building Operator of Canada Calgary chapter webinar. And in lieu of our monthly in-person meetings that we're still hopeful we'll be able to do next year, but in the meantime, we're doing what we can do to make sure we're reaching out to you and providing some resources and some education for you. And we get a chance to look at Les smiling with his little beard thing. Anyway, and so anyway, I want to welcome everyone, and hopefully everyone is doing well and staying safe, and we're all in this adventure together. So hopefully we're all looking for ways of helping each other through this whole I don't even know what to call it. It's more than a pandemic. It is it affects people in different ways. So all we can do is reach out to each other and support each other, and just carry on like we know what we're doing and stay healthy. So our guests, I guess I probably should thank some of our sponsors, and our platinum sponsors are Epic Building Services, Cougar Technical Services, and Gentech Field Services. As far as I know, that's still current. We've sort of, again, it's been, it'll be coming up on 2 years almost now since we all had to shut down for COVID. So but we're still here and we're still going strong. So today's topic is going to be it's going to be a question and answer session, and the presentation topic loosely is going to be HVAC recommissioning to maintain original design and tint. And we can go some places with this and go on some sidebars with it, but it should be fun. It's a topic that all of us throughout our career will be involved in one way or another. So so again, the more you know about it going in, the better the outcome. And so our guest speaker is Harry Wallen, and Harry is the principal at TMP Engineering. TMP has been a supporter of the Building Operators Association for many years, and I'm going to tell you a little bit about Harry. Both Les and I have worked with Harry in the field, and have grown to respect Harry and have invited him into many of our projects. How's that? And with a successful or an ongoing relationship. So so Harry's little bio here, it's a good one, so I'm going to read it out to you. I don't often do this, so but I kind of enjoyed this one. Harry graduated from SAIT in 1977. Wow, isn't that interesting? I graduated in 1975 or 4, I can't remember. I think it was, maybe it was 75. It was early 70s sometime. And that's a few years ago now, eh? Holy smokes. Anyway, and actually last week I had to, I was out on a job, and I was trying to figure something out, and I was trying to remember what I learned. I think it was 48 years ago at SAIT in a fluid mechanics course, and it was going, you know, if you think hard enough, it does start coming back, at least the fundamentals. And, you know, at least I was able to come up with some theories to how to fix the problem. So that's what education does for you. Anyway, Harry went to work as a design draftsman for a local mechanical consulting firm. Harry uses gifts in innovative design and problem solving to develop a successful career in mechanical consulting. Harry's consulting experience has been applied locally and for a period of time in England. Gonna have to ask him about that. I wonder if he was involved in that Canary Wharf thing. Anyway, in 1996, Harry became a principal in his current company, TMP Consulting Engineers. Harry is accredited with several professional organizations, APEGA, ASET, and ASHRAE. So welcome, Harry. I'm going to let Harry say hi to everyone.
Hello there, everybody. Wow, it's hard to believe. It's been 44 years, but the bigger number that I didn't realize was 25 years of ownership. That is, it's a special place, but in these days of pandemic and all that, it's a very lonely place, especially in the HR world when you have to make decisions that you really are grasping how to make the right decisions. And it really comes down to having an amazing network that's been developed over the decades. And
yeah. So for those that are watching, if you haven't been in one of our webinars before, you can type questions into the Q&A box, and then what I will do is I will ask Harry to answer them or embellish upon them as we go. You can type them in at any time, and then when we then I'll just put the question forward when the timing is right or whatever. If I miss out on you, we'll get you at the end, or hold up your hand and remind me. But anyway, also as a panelist, we have Les Anderson. You want to say hi, Les?
Hi, Les. It's always good to be able to participate in these. You know, one of the things that the Building Operators Association does in conjunction with our guest speakers is that we're talking a little bit about objectivity, and our objectivity is to support building operators at every level. That is to say that we intend to be a resource for education, and that we're always there for you at any capacity that you need us. Whether it as a consultant, we have technical concerns as part of our committees. So if you have a problem that's unique, or if we can't give you ideas on what to look for, or maybe what to uncover, we can always resource it to our contractors who support us as we support them, much like TMP, Gentech, and same with Epic Building Services. We can also direct you to who we believe could be your best solution to that problem. So hi, Les, I'm happy to be here and be part of this group as well.
Yeah, right on. So yeah, there's I guess there's a wealth of many years of experience sitting here on the panel, and so it definitely is a good opportunity for everyone out there to ask whatever questions that you feel are appropriate. I guess one of the first things that I'm just dying to ask Harry, what did you do in England?
well, it was interesting. In 1985, 86, I made a career change or a job change. I went from a multidiscipline organization, Lamb McManus, that was M&E and structural. And we worked on a lot of recreational facilities and designed places like the Speed Skating Oval and Repsol and Village Square. And it was interesting working on all these institutional type projects. There really wasn't a lot of variety, very because it's institutional. So when I joined TMP, first job I got to work on was there was a hole in the ground there. Last you would know, BP Center or Amico, it was first called, or Fourth Avenue place, and that was developed by Olympia, New York. And O&Y did a lot of really good buildings. Like they built them, but they designed them, but they also had a real philosophy of let's spend a little bit more money on mechanical systems or whatever so that their life expectancy would be higher. And so being in Calgary, made this connection with O&Y. But then in the meantime, our Toronto office was working on Canary Wharf, and BP,
I guessed it right.
yeah, and BP Center stopped, and they I still remember the day was St. Patty's Day in 1986. That says, "Be in Toronto tomorrow morning. We have a job for you." And it started off a 3-year journey on this side, and then of commuting back and forth to Toronto, and then moved to London for 3 years and worked on there. So the project was in Canary Wharf, which was a derelict old Docklands area, and the Reichmans were bringing North American technology and real estate strategies to the UK, which was it was just a totally different approach from life safety, especially smoke safety, but underfloor. We actually did a job there with underfloor, but overhead. But it was just weird doing a job where everything was electric. Was electric heat, and they didn't call them electric heaters. You developed a whole new terminology over there that was like everything electric was batteries. It was electric battery, the heating coil. But what it really did is just really open up my eyes to the international side. Worked on some development work in Portugal and in Paris that never went ahead. Again, if you remember, the early 90s was an absolute world recession and was actually a depression, and where a lot of companies at that time over there were actually cut the staff right back to principals, and it was survival mode. So through the whole process, and when I came back to Calgary in 90, someone must know my business partner, Brian Norrie. We'd worked together already at the other company. He'd gone over to TMP as well. And we realized we had this golden jewel, this golden goose that Toronto had given us. They shut down all the companies because of the recession, and Calgary became its own identity. And TMP had designed all these buildings in the 70s and 80s that we were able to do call it base building engineering with. And it really created an opportunity for us to grow from absolutely nothing. There was like 5 of us that were basically in survival mode after the 93 recession. And what do we do? And I think I'm just going to ramble here for a little bit, just give a bit of a background that really touches on the on your topic here of recommissioning. What it did is that all these buildings were brand new. and they were designed over and over the exact same way. And there was really not enough time for learning experiences in between. Remember, this is when calculators are still being used. Computers were starting to get used, like even word processing had migrated from typewriters to computers. So a lot of the design was done from developing relationships. And when a building starts up, there's always that time period. How do things start? You know, what was the intent? And I think people just took a little more time of doing personal designs were more complete as they were today, because you had to pencil line draw everything out and type everything out. You actually had to think the whole project through. You had to give a lot more attention to the details. But also the process when they started up, being a young guy in the industry, how in the world, you know, a guy like Les would call up, my space is hot. What in the world's going on? What did you guys design wrong or whatever? And really, what that really developed was a skill of, which I think has gotten lost, especially during pandemic times, is the use of our senses. You know, we've gotten so used to, is there an app for this, or is an app for that? Or who do I call or whatever? But there is nothing like going to a job site. You know, go to the job site. And I normally never sign out keys in a building, if it, like with Les was going down to Cantera, which is now Devon, but grab an operator and let's go for a walk. Because if you grab a set of keys, you're not going with anybody. But the whole thing was to actually ask all these random questions of operators. How's this? How's that? What's doing that? And to an operator might have sounded like a very, very disjointed conversation, but really what it was, I was trying to listen to what he would say, fill in the gaps. You know, this space is hot. When is it hot? When is it cold? You know, or even like, what are you seeing? You know, is it, you know, we use our eyes to see things, but I think the art of, we forget how to observe, to sit back, you know, just like you sit back and listen. You know, you sit in a meeting, your eyes glaze over because nothing is happening. But like even with our guys, we say, when you go to a job site, I hope there's nothing on the minutes for us. But I want you to sit in the corner and listen, because it's the best training opportunity that there is to cross train. Understand how a drywaller, what he's wrestling with the temperature, the humidity in the space, because he needs it to put on his mud, or the straightness, or a floor that has an 1.5 inch dip in it because of the concrete drying out, or whatever. So the developing those skills, even to touch stuff or feel it. You go into a mechanical room and you hear a motor, but man, there's a rumble to it, or there's something off. There's a different form of vibration. You know, it's the senses that I think of the use of them has been lost, and especially during this time when buildings have been shut down, where it's just harder to do. And like talking to someone a few months ago when buildings were shut down and unoccupied, and says, man, it's actually harder to operate an empty building. And I first had to think about it and says, well, that makes no sense. There's nobody here. But then I realized, you know what it is? You get a 500,000 square foot building, 30 floors, you get 80 people on a floor, you know, you get thousands of eyes that are walking around in the building, touching, feeling, smelling stuff. And they got this thing called the helpline, you know, call or do whatever. But they are really the proactive people that are telling you where the issues is. So if a building's unoccupied, you're relying on a security guard that's only been on that job site for two months and will be moved on to another project. So they're not really educated in walking around and what to do. And the building operator is tied up with paperwork or whatever they're doing. So that part is really missing. But I think it's the education on that side of the operations that it was fun to see guys like Les that we all started off as juniors, and then all of a sudden next thing you know, we all got gray hair and we are we still want to be young. And I think that's what's keeping me in the industry is just that's the one part. It's just the relationships that have been developed and are so key. And I think because we're talking about building operators, I've been there with you. I've scrubbed floors with you. I've lifted, I've taken out stuff, but it's important, especially as a consultant, to be there. You know, you can open up old blueprints or whatever, and well, it should be there like that, but we've all heard of that word called value engineering, where something is built to plans and specs, but no, let's save a little bit of money. We'd rather spend money on the architectural, have some shiny baubles, stainless steel or marble or whatever else, but the mechanical systems are really compromised, and they are yeah, they're shorted. But then it comes into the replacement then, and you know, 5, 10, 15 years later, all of a sudden, oh, something's not working right. And this is really where my passion really starts right now. From what I love, absolutely love doing is, I call it recommissioning or reverse engineering. And yeah, you put a boiler in that's, here's your 4 boilers that are 5 million BTUs each, but why do only 2 of them only fire the whole time? You know, is it because of redundancy? Oh no, that's the way it is. Or a cooling coil, you don't need to run your chilled water at 45 degrees, but 47 will do the trick. So when you're replacing products, it really then takes, you have to spend time with the operations and do some reverse calculations and find out how many people are actually in this space. Well, there's a shadow that's on this building now that the cooling plant is oversized. You know, I think we all know that we can get away with oversized heating systems a lot easier than oversized chilled water, because you know, when you're looking at the old technologies, when chillers were 0.8, 0.9 kilowatts a ton, that dropped down to 0.6. But now you got modern technology of the magnetic bearing chillers where I don't know, Les, if you've seen these guys, but we've got a job where we put some of these magnetic bearing chillers in and running 42-degree condenser water into it and seeing 0.12 kilowatts per ton run out of it. It's just absolutely phenomenal where that technology has really come to light. But it really takes time. You know, it comes back to relationships with the guys that are in the trenches, because they really are the front line. You know, I don't know who's online or whatever, but if you guys are the building operators, I think a lot of times you're very, very, very underappreciated what you actually do, because without you guys actually using your senses and figuring that out, you know, the most important thing, I always say when looking at a building, priority number 1 is protect the asset. What is the envelope doing? You know, understand the systems. You know, what if my one boiler goes down or whatever? You know, we're now heading into some cold weather and the wind chills. Where are my holes? You know, where's my leaks? What dampers haven't I figured? But protect the asset. What can I actually shut down and still operate the building? Because you got to consider the building is fully occupied and people are paying really good money on their rent and operating costs. keep it going. So I think part of the recommissioning, I think just as it applies to the engineering side, to get the right products in there and the right system capacities, I think it's also important that from the operations side that they are actually test drive their systems, work the safeties, work it, find out, run it through. I know it's easy to pick up the phone and say, get a contractor to do it for you, but you know what? They're just walking into the building just as cold as the next guy. And when I was thinking about what have I been exposed to, and let me just share a picture that sort of, it's not complete. And that's the thing, but I couldn't blow the picture up good enough. But I was looking at downtown Calgary, and it says, over the years, what buildings have I actually looked at, worked in, and all that? And it was just, I was just driving up and down the streets mentally, and I don't even know how many there are. There's probably 40, 30, 40, 50 in there. Doesn't cover everything. But you know what the unique thing about this is? They're really in a downtown office setting, two very distinct systems. It's either a centralized air handling system or a compartmentalized system. And the principles of each are the same. You're moving air and you're moving water. And where's it going to and how's it getting back? And the taller the building, you know, you start playing around with stack effect. You start playing around with, I think the biggest challenge right now is actually what LEED has done in water consumption, where low flow fixtures have really made it difficult to, it's on the water booster line sizing, and then the PRVs, because all the PRVs that used to be 2 and 3 inch, now you get a urinal that opens up and it needs only a little squirt of water to flush. And when you really think about it, the old line sizes that were there, the inch and a quarter, that was only like 4 feet of water that it took out of the system. And then if you don't have the water hammer arresters, you know, all of a sudden you get water hammer that happens. And we all know how the arresters were built during that time. They're just a 2-inch piece of pipe that was 3 feet long, filled with air.
Yeah.
That air is all been absorbed. So with all the quick closing valves and all that, you know, creates noise and water hammer, which therefore puts additional stress on piping systems, etc. But it's really the recommissioning stuff that really drives me, because we at TMP, I'd say 98% of our work is on referral, and the stuff I always complain about. Why do I only get the ugly stuff, right, Mark? You know,
I love it. I love it.
the last new building I designed was actually TransCanada Tower, TC Energy, and that was in 1990, 90 something, 99 or whatever. But again, when you get tied up in a building like that, it's about a 7-year process from the first pen stroke that goes on to a blank piece of paper to when the tenant moves in, and sort of had that 1 year of that. So it's not an overnight thing like a downtown high rise as opposed to a strip mall. So over that time, you really get to develop relationships with either design team, the construction team, or sometimes it's with an existing owner that is going to move their operations staff over from someone like another building. And hopefully they hire a operations manager early enough so that they can see it through construction. You know, the picture I showed before, I've seen a lot of these during construction. So you get to sort of memorize where a lot of the systems were and how they were put together so that it becomes easier to troubleshoot.
Yeah.
But again, back to the basic senses. Listen, watch, shut up, just listen. I can't emphasize that enough. Anyway,
I just
I've
want to take
rambled
this.
long. How's that for a long answer for a very short question?
Well, excellent, excellent. Well, the reason why you're invited is over the years, we've all enjoyed your storytelling. So that's why you're here. You're here among friends. So I just wanted to take this opportunity. I just looked at the list of people listening in, and one of them is an individual that I met last week. His name is Louis, and he lives in the frozen boreal forest of Alberta, and he has a brand new school that's high tech. And when I was there last Monday morning, it was minus 35. So welcome, Louis, and welcome to our profession. And we're all in this together, like I said. So lots to learn, and you have resources that you can use that you're welcome to, and like our other operators that belong to our association, and good luck, and hopefully I will be able to mentor you a little bit through the process of becoming starting out new to building operations. And there's a lot to learn about a lot of things, but what Harry is talking about is the basics of you got to pay attention to what's going on around you. The robots, like the automation systems and stuff like that, aren't smart enough to operate the building. That requires a human being that sees and hears and interacts with the environment to make it all work. So that's sort of along the theme that we were just talking about. So welcome, Louis. Anyway, my next question, well, I'm not sure what it really should be, but this is sort of with building recommissioning, and you're right, Harry. Our profession is very much about relationships. We can't do it all on our own, and we have to have relationships with other people around us. And those people, we rely on each other, whether it's the engineering people or the commissioning people or the operations people or the people that are occupying the space. We're all in this together, and we all have, we need to participate together with ideas, or none of us have a full understanding of what's really going on. And so communication is key to our profession, and understanding what you're seeing and feeling and smelling. But anyway, my question is sort of related kind of to COVID, and maybe not. So the question would be, are you doing anything different today from an engineering point of view, considering ventilation due to COVID? Do you have any thoughts on this whole process? I know that, we're 2 years into this almost, and at the first, nobody was quite sure, but what we did know was if what you have isn't operating correctly, then the first step is to get it working correctly. And then you might be able to make some changes to improve the indoor air quality, but you got to get it working right first. Anyway, I just wondered if Harry has some comments on that or some experiences.
There's a phrase that's it's coming more and more common. What was old is new today, or the new stuff was the old stuff that we used to do. And there was this time when systems were allegedly sort of over-designed and energy were not as energy efficient or whatever. But the key was always high ventilation rates. You look at what the schools used to have, it was when people said, oh, it's a constant volume terminal reheat system with ducted returns. You know, that was the state of the art in the 60s and 70s. And that, when you think about it, yes, it's a bit of an energy pig, but man, oh man, it checked all the boxes in higher ventilation. The filtration technology probably wasn't there at the time, because typically it was either, or the standard was actually higher, because it was always a roll filter, a giant 18-inch, 24-inch bag filter, you know, or with a pre-filter on it. So now, you know, jumping forward, we went through, when ASHRAE changes their ventilation, that went from 20 CFM square per person down to like 7 CFM, and then now it's sort of crept back up. But technology has been able to step in there and, you know, cover the CO2 side. And again, really, that should be the measurement of the efficiency, would be CO2s, because do we need to overventilate something that isn't there? Now, there's a big difference between ventilation and circulation, and is really confused a lot by property managers, leasing guys, because it's, well, what's my air exchange rate? Well, your air exchange rate is typically 6 to 10 air changes per hour, depending on your system. Your outdoor air rate is only about 1 air change per hour. And this is where Central Systems wins hands down, because during the time when they were able to use economizer, free cool, they got 100% outside air. So their air ventilation rate is huge and fresh. But when you're in a tower that only has compartment units, and or buildings that have been designed with heat pumps, you know, that's sort of the trend in schools now. Put a heat pump in every room and then pump in the minimum amount of ventilation in there. You really got to make sure that you do have that air that's clean. I just finished a project here last year at Arts Commons, where you have really high audience, because that's what it is. It's either lots of people or no people. And again, trying to open it up, you know, what do you do for ventilation? What is, you know, what do you do? And so we wrestled with, yeah, we bumped the filtration rate up, the 8s and the 13s, but then we also looked at the different technologies that were out there, GPS and ultraviolet. But we ended up on that one, we ended up actually putting return ultraviolet into each one of the return air fans, because they're giant oversized boxes. And really the reason was the velocity through these plenums are slow, so the interaction time was greater. And again, that technology has also been around for a long, long time. And yeah, it's just a light bulb and that. I know in the early days of the GPS, people were concerned about that the smell of ozone being created or whatever. and again, there's products that were a year ago were really good at residential level, but at the commercial level, there's still some development that was happening. But it really comes down to air circulation. It's still the key. We did a job, story time. CP Rail, it was their network management center. They moved from Montreal to Gulf Canada Square. And so they had this operation, 30 desks with the radio operators and then the network management people. And this place ran all the trains from Winnipeg all the way to Vancouver Island. A couple of years in, all of a sudden the complaints, oh, this place is stuffy, this place is, oh, it's dirty, it's not working and all that. So you had someone like C5 Plus came in. Les, you're very familiar with Dr. John Dean, and he went through and did an air quality study at the time. And it revealed a couple of things. One, people working at night shift like to have spaces 2 to 3 degrees warmer than the people working at daytime because they don't see the sunshine. But the carpets were wearing out, and they were looking at the diffusers at the ceiling and saying, oh, there's all these black smudges around it and all that. So we did testing on the filters. The filters, even though that they look dirty, were actually, you need a dirty filter to be dirty for it to work at its efficiency. It was just normal. But what it turned out to be, everybody was blaming the mechanical system. But what it was is the housekeepers were coming through twice a day and just using an ordinary vacuum cleaner with a beater brush without a HEPA filter on it. So all they were doing is stirring up the dust, and it against the diffuser, it would ionize. Like they had everything there. We put in fan-powered boxes so that they could have high air circulation rates and that. But everybody was looking at, oh, the place is dirty, but they were looking in the wrong spot. The problem was the vacuum cleaners. So air quality is, it's just attention to detail. It's now, you used to get a MERV 13 filter, which used to be like an 8-inch cartridge. Now, they're smaller. So that technology has really grown. And again, do you run the building systems longer? It's an energy cost, but in that case, is it just a recirculation where all you're doing is cleaning it? But I think it starts at housekeeping, not on the mechanical system. I don't think you're expecting that answer.
No, I agree with you. Yeah, absolutely.
Les, you've had your hand up for a long time. You're on mute.
No, Les doesn't want to talk to us.
I do. I'm sorry. I had my hand up because I'm kind of backed up. When I listen to building operators and they're talking about, what their concerns are, and we talk a little bit about what the original design intent was. And so a lot of the building operators, when they come into a building that they've never been in before, they got hired and here you're going to be looking after this facility. And they're looking around for the O&M manuals, and they're looking for the as-built drawings or record drawings, and they can't find them because they're lost. And so they have no idea what the original intent of that facility was. They have to operate it, but they don't know what the original is. Where do they go to, Harry, when they want to find the original drawings, the original O&M, the shop drawings for those buildings? Can they go to a library someplace and find them?
I'm going to say that TMP probably has the biggest library of all buildings, because we've collected drawings and maintenance manuals and shop drawings of every place we go to, because again, there's been a lot of jobs where I've gone to where let's go change something, and let's go to the site. Let's go out into the area first. No. Show me the junk pile where all those rolled up drawings are. And I'd rather spend some time and look through there, because there's probably a lot of the answers are there, but they've just been not deemed important. Drawings or even binders or folders. The biggest problem I've seen downtown is these buildings get sold from one guy to the next to the next. Then someone just tosses it or doesn't find it important. Or the worst thing is the drawings get centralized, and then nobody can find it in the filing system, because the filing systems are too complex. But take a pump. You can get a model number, you can find a catalog, or the other thing you can probably find on is the James Electric sticker on it, where you can actually go look at something. If you can't find it, there's still old catalogs around that are there. But again, this is sort of a thing that has gone away, especially some of the products that are no longer made, like Canadian Chicago blower and Sheldon's fans and some of the other ones that have been bought out by a variety of people. But there are ways to reverse engineer, and thank goodness there's still people that scan this stuff and throw it up on the net and put those documents there. But
they can't go to a central library like the city of Calgary who approved drawing. Go to the original. If they were to go to Emmons Smith Anderson and say, well,
you probably have to go to a consultant, and hopefully they've kept them, or some of the old manufacturers reps. They'll have kept some of their old supplies.
Oh, I know. We did that in one of our buildings that was built in the early 70s, and we went to BAC and we got all of the shop drawings from the cooling towers that were there. So the operator has got a job to do. It's not just looking pretty in the boiler room. The building operator needs to be a curious person.
It's app time. I need to work on my apps. Yeah. No, it's
Brian,
you got to walk the floors.
That's right. And we teach a little bit of it. We call it SciApp, and that is, what is the relationship? What is a good building operator? What is his character? And he's got to be able to listen and to hear at the same time. Know what the building sounds like when it's running well, and know when it is not running well. There's a sound to it, and also visuals, pressure gauges. Is it, to mark where it's supposed to be when it's running normal? So when it's running good, a good building operator marks down what those conditions are when it's running well, so that he's got a point when it starts not to look well. If he sees, oh man, I'm running a negative pressure on the suction of that pump, that's why it's banging. It's normally got to be positive. So a good operator is a curious operator. And then
absolutely.
So where does he go to for resources? Who does he believe when he says to the guy, well, that's the way we've always done it? That's a terrible thing to say. There's always got to be a better way to do things. It's building relationships.
That's relationships. And again, you guys have seen enough of me when out comes the red pen and out comes a napkin, and let's draw a schematic of a system, or let's document what we know. Office towers are an absolute luxury from an operation standpoint to operate, because if something is just not working on one floor, you've got other floors that you can go and reference to. And so how does the 22nd floor compare to the 12th floor when I have that same, or the floor above and floor below? And what has changed? It's I walk through mechanical rooms and I see lots of lists and check marks and all that. But sometimes I wonder, do they really understand what those check marks are? Or is it just a routine, how fast can I do my rounds? But sometimes, back to the recommissioning, like even on my designs, I've always said, we go design something or do something, then I actually go back and do a hard look at it from all aspects. Was it constructible? Was it maintainable? Did it actually do what it was meant to be? Or even at the end, did I take the knowledge that I put together during design, did I transfer that to someone else? Because it's really hard to put a lot of that information in writing. Old school was sit around the campfire and share the stories and how did this happen and that. And I think like this organization is key, because you have to share the stories, the knowledge, the wealth. The guys that want to that are coming up and want to learn, they're sort of at a tipping point here, because so many people have exited out of the community, out of the workforce. But look at the color of the hair of the three guys that you see on the screen that still have the same passion, that want to share and pass on the legacy, because knowledge is easy to get. Wisdom takes a long time, and we've said it 1,000 times, relationships applies to so many things. And but I think it's just that cross training that is so important. Anyway, Mark, up to you.
So one of the other questions maybe, I guess Les and I were talking before the meeting a little bit about reliable design, and we both had our own, and you sort of spoke to this in your own way. So a good solid design that we consider reliable, when you introduce new products into that reliable design, then you need to be prepared to understand or see the unforeseen and accommodate that and somehow and move everything forward. And technology changes. We're using new toys, and some of us have got new shovels in the sandbox, and so we're constantly adapting to something new. But really, I guess what comes down to it, if you've got a solid backplane to work from that has few vulnerabilities, then it gives you the opportunity to go and explore different products. Now, part of the recommissioning process is if you have something that maybe is not a reliable design, as maybe was thought 30 years ago, then what can we do to improve that so we can move forward, I guess. And so I'm just kind of setting you up for a comment on that. It's everything evolves constantly. It never stops, is what I'm trying to say. So we have to prepare ourselves for that as an operator.
I did a job probably about a decade ago. It was to upgrade, I'm going to say seven secondary systems on a primary heating loop. And I was like, okay, how are we going to do this? The easy way to do it is just, it's a 4x4x10 pump. Let's just get another 4x4x10 pump, put it back in. And we actually said, you know what? your guys' gauges and all this doesn't make sense. So we went through a process where we got a balancer out, and we actually did water balancing, water surveying, not balancing. We wanted a survey of how the systems work. It was 2 pumps in parallel in each one. Then we looked at the flow. Okay, then we spent some time looking at the delta T's on the system. Well, the heating systems are always designed on a 20-degree delta T, old school. Today, 20 to 30-degree delta T. Chilled water systems are always designed on a 10-degree delta T. When you start to look and see them at 5-degree or 2-degree delta T's, you start to say, I'm flowing a lot of water that I don't need to use. So then we actually went back and did an actual pressure drop calc, because you could figure out how many pipe diameters and elbows and T's and all that was in the system. And it was probably one of the riskiest projects I did, because in those 7 systems, I stripped out, I think it was 175 horsepower of motor. Drastically changed the pumps, changed the flows, changed the heads and all that. Married it closer to try and get back to that 20-degree delta T. The basic pump and fan laws, pressure drop changes by the square, but energy consumption changes by the cube. So if you can save 10% on your static pressure or pump head, all of a sudden you are saving 20-30% on that. That's really the fundamentals of why a VFD is so effective. And we have this argument in-house with Charles. He loves using VFDs, and I hate using VFDs because it's another piece of technology that will last 5 years, and then you got to replace it like a computer or a phone or whatever.
Yeah.
What does it just take to, let's trim the impeller or get the right product in place and use that benefit by that energy over the long haul, and not put more 2-cent fuses in the system. And that's the only downfall what we have today with the technology, is we're so reliant on computers and someone else doing the thinking. And if you still, they're a beautiful asset, but I think you still need to be able to predict what the rate of change is. Like if I go to a Freestat, which is an old mechanical device, and if I put some ice to it, it better trip. I shouldn't rely on something like that. But if it's just a temperature probe, I should be able to work it back and forth. But on pressure, the exact same thing. You need to be able to anticipate the results of making that change. So that's why we rarely hit design temperatures. Like in cooling, we get a couple of days. This past summer it was close, but you know what? We got thermal mass in the buildings that control the load. Everybody says, well, I'm going to shut the system off right at 5 o'clock or 6 o'clock, and then I'll come in at 3 a.m. in the morning and start it up so I can get a jump on the load. And I posed the question the other way. It says, the sun is still shining at 6 o'clock and 7 o'clock. So why don't you run it, cool down the west side of your building and take the load out of it then, so that the mass of the building isn't overheated, and then you're struggling in the morning to take it out. So I think it's a little bit of a rethink of that, but it's, Les said it, look at the gauges, look at the temperatures, understand what they mean. So I think it's an education. I bought a new car this year. Came with a manual that was so super thick on it. But if I don't understand it, I also can go back to the dealership and say, please explain this or that to me. And I think that's sort of where the operator is. he's got to be able to be the guy that can read the manual, read the plans, and anticipate what it is. And if you can't find out if it's working the way it's supposed to, find an answer. Don't give
Yeah.
up.
Yeah, and you know, expectations are that you'll come up with that answer in 3.21 seconds as everyone's staring at you. So you got to do your homework, right?
Well, yeah, and that's why I showed the picture before. It says, you know what, being exposed to 30, 40, 50, 60, 100 buildings over my career, your library of is bigger on the type of systems, but it's also the relationships with operators as well. I treasure that as much as you know, the technical side.
Yeah, absolutely. I mean, where else would you be on a Friday afternoon if you weren't out visiting, right? And you're
Shooting the
not just
puck.
visiting, right?
I think
Yeah.
it's that and much more. It's relationships not only with the designers and the contractors and the suppliers, but it's also the relationship with keeping the building operators in tune with each other as well. You know, whether it's another coworker in another building that you can ask a question for without feeling belittled for a question. A question is very
Mhm.
important and deserves a good answer. It deserves an analyzed answer, and that it's important that once something that is irregular has shown up, and you can't figure out what that irregularity means. You can't analyze what the problem is. To have the confidence to go to somebody with that will give you an opportunity for a resolve. It may not be the right resolve. It may only be a guess, but at least it's heading you in the right direction. Should I shut it down? Should I turn it off? Should I switch over to another pump? What do I do to the other one? Those questions are often said that not every building operator knows everything. But if you were to put us all together, we'd be a heck of a good operator, in fact. And so it's a resource. And the Building Operators Association has been that. We always said, if you get stuck for something, you can call us up. And this, Kyle is going to hate me for this, but we have a technical committee that we can resource out. And we could call somebody like Harry up to say, you know, this air is not being delivered. They're always, and he can come up with an idea, or maybe he even come up with a solution for it. You may pay a little, you may pay a lot. It could be needing a redesign, but we always have to look at one for another. It's a big world, but I'll tell you what, it's very small. When things go wrong, we're always willing to help each other be able to perform the best that we can. And so it really is, the building operator is a very curious person. A good building operator is curious. What makes it do that? Why does it do it? What happens when I turn it off? What happens when I turn it on early? Like we were just talking about, Harry. What happens if I let that air conditioning unit run for an extra hour at a reduced capacity till the sun goes down, as opposed to trying to hit it at 100% for the first 2 hours after it's heated up the whole mass of the building? Where is the advantage? Somebody can tell you that.
Yeah, and we also have to remember that every building is unique in its own way. And but there are some commonalities between many of them, and each one has its own character. And so it's just a question of understanding the environment around you and how best to work within that environment to work smart. You don't have to work hard, but you can work smart. But anyway, I guess we've used up our hour of Harry's time. Thank you very much, Harry. I enjoyed this very much. It's always very pleasant having a conversation with you, and then hopefully our participants have enjoyed it as well. Any parting comments, Harry?
Yeah, from my favorite author, Dr. Seuss. Green eggs and ham. until you try it, you'll never know. And that's what the encouragement is. Go out and touch things, listen to things, feel things, and go talk to a brother in the industry. That's all I can say. You might like it in a box, in a fox, with a rocks on a train.
Airplane.
Very
Exactly.
good. Any parting thoughts there, Les?
Actually, got to say is that I'm sad, like you are, Mark, that we aren't getting together. This variant is causing us to do more and more of these. I don't know if this is going to be the new normal or not, but again, it's important that we continue on educating the operators. That's our goal and objectives. Well, we still hope to have a trade show in the whether it's going to be in the spring or whether it's going to be in the fall, but we want to get back to that where we can reach out and buy each other a beer, shake each other's hand, but we're just not there yet. We will head that way eventually, but it's important to look after, because the average age of a building operator is now 60 years old. Isn't that terrible? This is 60 years old. Holy smokes. That's a lot. That's a lot. We should have been retired a long time ago.
I do recommend retirement, by the way. But we're never, ever really completely retired. It doesn't work like that. We're mentoring, we're educating, it's what we do, right?
Giving back, give back, pay it forward.
Yeah, well, Terry, thanks for sharing with us your thoughts, and maybe we'll pick another topic and you can dwell on that for a bit. I always like that.
No, it's been fun. Thanks for the honor of the ask, and hopefully I didn't disappoint.
That's all.
That was good. All right, well, thank you very much, everyone, and we will be seeing you in January. I'm not sure of the date. I don't have a calendar, but it'd be the second Tuesday of the month, whatever that happens to be. And I haven't decided, or we haven't decided what the speaker is going to be. So Lester, we need to get on that. I hope to get the generator guy going, but
yeah, Miguel is awesome. He's going to actually show us what a building operator needs to do checks on a generator as he goes through, and maybe I'm trying to encourage him to run up the generator so we can look at the temperatures and the voltages and how do you start a generator. Not only do the daily checks on it, the weekly checks on it, but actually run it up and watch that puppy perform.
yeah. So and again, thanks Louis for tuning in, and don't worry, the pros from Dover are working on your fuel problem. They've been emailing me during the meeting. So we'll get your generator going so you don't freeze your ass, bud. We'll talk to you later. Cheers.